in this recording, we will take a look at finding volume of a solid of revolution. But now the difference is that the rotation will be around other axes besides the x and the y axis. So the rotation could be about any other vertical or horizontal axis in these examples. Let's take a look. For example, we're going to take the region bounded by y equals the square root of x y equals 0, which is the x-axis, and x equals 2. And in part A, we're going to rotate that region around the line x equals to 6. So way out here, let's say is the point 6, we're going to rotate it around that point, or that line, I should say. Okay, again, we have a choice. Either a horizontal or a vertical rectangle here would be appropriate. I think it's going to be easier to select a rectangle that is so this way with a thickness delta x. Again, it really is not such a big deal to do it the other way. It can be done. This is just one possible answer. So if the rectangle is parallel to the axis of rotation, we know it should be the shell method, right? So the volume equals, with the shell method, the constant is 2 pi. We want the shell radius. Since the rotation is around this axis, the shell radius will be whatever this distance is given in green, and the shell height will be this distance. Okay, shell height is easy and shell thickness is easy. Let me plug them in. The thickness is dx. Shell height is given by the function, in this case the square root of x function. So I just have to worry about the shell radius given by this long green arrow. Okay, what we know is the total distance from here to here is 6. And distance from here to here is x. So that tells us that the green arrow, the length of that should be the difference between the two. So it should be 6 minus x. So that's what I will write in my integral for the shell radius. And as to the limits, they will come from the x-axis. Just look at from where to where that these rectangles will extend. The rectangles will extend only within the actual region. So that tells us that the limits should be from 0 to 2 along the x-axis. Again, to integrate this, you could distribute your square root of x and evaluate it. I will go ahead and give you the answer. It should be roughly 66.84. Okay, we're going to also rotate this region in part B around the line y equals to 4. So let me start another graph for that. This one got too messy. It's going to be rotated around y equals to 2. Again, you have a choice as to how you want to select your rectangle. I will select it to be, once again, this way with thickness delta x. Since this is perpendicular to the axis of rotation, now I must select the washer method because there is also a hole in the region generated. So volume with the washer method equals, the constant is pi. What I need here is big R squared minus little r squared, and I've selected dx. The limits are going to be from 0 to 2 for the x variable. Now let's see what our big R is for this question. Big R is distance from here to here, from the axis of rotation to the outer part of your rectangle, to the farthest part of your rectangle. That distance is a constant, is it not? So I can just go ahead and put 2 there. don't forget to square it, minus the inner radius, which is this distance. Well, we know what this distance is. This is what we call y. In this case, y equals root x. So if this one, the first one was 2 units, this one is root x units. The one that we're looking for is 2 minus root x. And that is what needs to be squared as our inner radius. So quantity 2 minus square root of x altogether squared. And we are integrating with respect to x. And that's pretty much the setup for this question. And once again, to integrate it, you could expand your binomial and then integrate term by term. Okay, so again, this is not going to be a difficult integral if you expand your 2 minus root x binomial squared and simplify, then integrate. I will leave you with the answer there so you can check. It should be 5.54, and then we should multiply it with pi. So I'm going to leave it as 5.54 pi. Excuse me, what is going on here? 5.54 pi. And that is about 17.4. Okay, one more example about just the setup as to how we can set up these questions when the rotation is done around a different axis. Let's take a look at this example. We have the region shaded in brown, and the rotation will be around the line x equals to 4. So once again, pick your rectangle. We have to pick it this way again. This ensures we have the same neighbors on the top and the bottom throughout the region. A rectangle selected horizontally would not give you the same neighbors on the right and the left throughout the region. So this is the selection that we want. And since the rotation is around this axis, and it's parallel to that axis, we know we have to use the shell method, right? Okay, with the shell method, we want 2 pi times shell radius, which will be this distance. Again, this is x equals 4. Normally, distance from here to here would be your x. The entire distance is your 4. But we want just this part. So that will be 4 minus x. That's our shell radius. And as to the shell height, that is the length of your representative rectangle. I'll get rid of those so as not to clutter the picture too much. So I have shell radius, which is 4 minus x, and shell height. Since you have a function on the top and another function on the bottom, the height of that shell is the difference between the two functions, which is x cubed plus 2 minus quantity 4 minus x squared. That will become 4 plus x squared in the subtraction process. Thickness is dx, and the limits, think about where these rectangles are going to go from where to where. On the leftmost part they are here, on the rightmost part they are here. So they're going to be basically going from 1 to 2. And the only thing we can do is basically to simplify it a little bit further. Would be 2 pi integral 1 to 2 of 4 minus x times x cubed plus x squared minus 2. And again, we could evaluate this. This one is going to be tedious. You have to multiply the binomial with the trinomial. It's not going to be difficult. It's just going to be messy. And some of the questions on the test I will ask you as a setup question, because for these problems it is more important for me to see that you really know how to set it up than how to integrate a polynomial. These questions do take a while to get used to. I would suggest that you go and do some examples now about rotation around different axes.